We got people, we got a small meeting, so let's get started. Let's start with company update.
More tiny boxes are being made. We shipped 2 out last week. Got like 5. Some of them don't work. I fix them. Then the project for comma has been taking a lot of time. The build the computers for comma project.
Oh.
Yeah. So that's coming along too. Comma has made a special order with Tinycorp for some computers that we've been working on.
Make a special order, and it's kind of also built by comma.
Yeah, well, comma does the building. Yeah, no, but it's when we did all the part selection and purchasing. So
makes sense.
Yeah.
Okay. So I think the big thing is Rangify.
Yeah. So what I realized was, like, you don't need to push views. The only thing you care about doing is indexing in the appropriate places. So you can actually just push indexes through views. And the way to think about this is more that it's split. Like, if you think about a kernel, if you think about like the axes of a kernel, you can split the axes of a kernel like horizontally. So you can do some things only in only on a few axes. You don't have to do. Imagine you have a whole model, and you want to take the batch out of it. You can do this. Like, you can completely separate the range for the batch from the entire rest of the model and inference. And you can't do this if you're doing like normal view pushing kind of stuff. There's no amount of view pushing that's going to. Yeah, that's the simplest case, and the case that I focused on that I think leads to like all of them. So if you're running a model and you want to run the model on, it's at inference, and you're running the model on 10 examples. Imagine the difference between running all 10 at once versus running a loop, running one example in each one of the loops. So you need 10x less memory in order to do it like that. But you're also going to have, in the limit, 10x more accesses to your weights. So that's the trade-off. You're trading off locality for well, in that case, there's no recomputation. In that case, the computation is the same. But there's places where you can trade off and like recompute instead of storing. So that's what flash attention is. When you get to a point where a node has 2 children, so we've always had this problem when a node has children, and the children have different views. What do? You can't push the view. There's no way to push view, so we would have to just insert a contiguous there. But again, the Rangify insight is that contiguous doesn't have to mean contiguous on every axis. Like a normal contiguous, what that means is end every range in the indexing and create all new ranges for the indexing. But if you do that, you're not going to get flash attention. You're going to get 3 kernels. So the old flash attention fuser would push the range. It would push the views anyway. You can push the views anyway. So if you have a child that has 2 different views and you push the views anyway, what happens is all the parents duplicate. So you're going to get replications of the parents with the different views being pushed. But this is bad because now you're doing recomputation. So what Rangify finally lets you do is say, okay, I have 2 shapes of 4 dimensions coming in. The only axis they mismatch on is axis 3. I'm just going to end ranges for axis 3. And then when you end those ranges, that end range is actually a store followed by a load. And that's your intermediate buffer. I believe that's completely generic. I believe that also works for upcasting for locals. If you see that I pasted one of the upcasting things, yeah. So I'm working on it now for reduces. The reduce right now that it's generating is is still... The reduce still has like a weird loop because it's not expanding the register. It's not expanding ACC 0.
Huh?
But yeah, I can fix that. And we can also think about changing the semantics of the reduce op to be... what halide does is it creates the buffer that you're going to reduce into, and then the size of that buffer can actually determine the
which axis you are reducing.
Which axis you're reducing on, right? And you can still get rid of the ones at the end, right? You can have something like if you want to reduce, your inputs are like 16, 16, your reduce into is 16, 1, and your output shape is 16. That's all totally fine.
Okay.
So yeah, I still think we should get rid of the ones there. So yeah, I'm just going through and re-adding each of the optimizations to Rangeify. Rangeify goes really far. You can delete the shape tracker now. Like, there's no longer a need for views for the shape tracker. And I know it's like sad to like kill something that's existed for so long, but
great.
So, well, we can keep it alive and test and make sure that Symbolic can find all the patterns.
I don't know about that. We can keep it for a while, maybe.
Let's make sure Symbolic can find any patterns that are important or any.
Oh, so that's it should at least match. What's the precondition to remove it?
Yeah, I guess.
But after that.
Yeah, after that, then yeah, we can just delete it. Bye shape tracker. It's been nice having it, but yeah, we push ranges through views, and then the eventual goal of this is there's no reason this has to be done on the kernels. It can be done on the big graph. You could push ranges through the entire big graph. This gets into actually the user putting ranges on the big graph to specify things like
gradient accumulation.
Well, you can specify gradient accumulation. You can specify batching. You can
stunning MNIST.
Stunning MNIST. Yeah, you can specify the actual optimizer itself. You should be able to specify things that look like scan, like RNNs.
Okay.
You should be able to express like RNNs with O of 1.
Sure.
Yeah.
Are we getting this in a month?
We're getting this in a month? Probably about how long it's going to take, yeah.
Okay.
Yeah. I mean, look, it took a while to figure out what the formulation should be, but it's not like I was like doing nothing. I did a whole lot of refactors. Notably, like define reg needed to be refactored the way that it was. And yeah, I mean, all the way that I refactored reduce into load store, all of these things were completely in the right direction. I didn't do anything wrong. I mean, the wrong stuff was like shape tracker and views, but I think that was kind of hard to know at the time. Right? Like we were so focused on this idea of a single kernel, but then you start realizing that you need to find solutions that will work for the entire graph. And then you realize that view pushing is not going to. You're not going to be able to push all your views all the way to the left of the huge graph. That's never going to happen. And then this also gets into the other thing that makes this all hard to move to the big graph is that we need some quick way to do like deduping. You don't actually want to reassign ranges to new areas if they're duplicates of other areas that it's seen already. Right. So right now we do this with like once we split it into kernels. Like think about how few of the UOPs in the big graph actually end up in a kernel for Llama, right? Because every time you're doing like 10 layers. So yeah, I mean the dream thing to do is we could also just write Llama to use ranges in the big graph, and then that fixes that explicitly.
Yeah.
But you could also, if you could figure out how to do that implicitly, if you could figure out how to re-extract loop semantics from a graph. Oh, hey, this is just that same thing repeated. Cool. I can just merge them together into a for loop. So
great.
Yeah, I mean, it's not. Yeah, so it's just, this has all been a completely steady progression. Looking back on it for the last 2 months, and it was going to the right place. So
great.
Yeah, and now we can generate. That thing is real flash attention that I posted on Twitter.
Do you need like tensor core?
You can. I mean,
that's real.
Yeah. I mean, the QK thing should be using tensor cores. Yeah, of course. But like, this is all
structurally is there.
Yeah. I mean, tensor cores are an optimization after this. But yeah, there's no reason that it shouldn't be able to see that reduce small pattern and add tensor cores. And now that we have the like expands properly, like we can say, oh, this is actually expanded over this axis. Cool, this is a tensor core.
Great, excited. We also need that for memory stuff. Okay, so let's relate to the next point.
Wait, what? Oh, that's a different problem.
Okay, that's a different.
That's a different.
Okay, anyway, let's move on to MLPerf Llama. So Walter is not here, but he did a bunch of work to pipe the data loader. So now we have a data loader that we can train the MLPerf Llama. So for MLPerf, I just learned that in the upcoming round, so Bird is being killed and replaced by Llama 8B. So there will be 2 llamas, one for 8B and one for 405B. Our contract is on 405B, but AB is the new Bird, although it's much bigger than Bird. So now we can train that. You can see my drawing on the whiteboard in the Llama 405B channel. And I added some tricks like gradient accumulation and another PR for optimizer offloading to CPU, which we will need eventually for the 405B. We probably don't need that for AB, but we definitely need that for 405B.
Do we have the test? Do we have the eval working?
Eval is working, but now it's very slow, and Westbury will be working on that.
Great.
Yeah, so it's less of an issue because for Llama, we don't even train over one epoch of the data. So training loss is very similar to the eval loss that you expect.
Yeah, but we're seeing training loss go down on 8B. Like, how long is it going to take? I know you put it on the board. Does that mean it trains, or does that mean it finished training?
That means it kind of runs with global batch size 32, and the loss is going down.
Okay.
Because...
But we haven't actually checked if it's converging to the right.
So the initial random log perplexity is 10.5.
Yeah.
That's basically just log of vocabs.
Yeah.
Because it's like a new vocab set. The required target is 5.6. So it needs to be lower than 5.6. I trained a 1B for 24 hours and it lowered to 7.5-ish. And I doubt it will go much lower because it's a 1B model. 8B model with a much smaller batch size is running now, and I just checked, it's like 10.1 after 10 hours.
It doesn't seem right.
No, but think about it. 405B model is 7 days to go to that.
Yeah.
So why is that not
well, I mean, these things are in log space, right? Like even 7.4 is a lot.
No. So initially it's a lot faster, right? Is that why you're...
Well, yeah, that's what I'm saying. Like, I expected to come down from 10.4 to like 7 really fast. And then, sure, I expect the difference between 405B and 8B to be more like 5.6 versus 5.9.
Part of the reason is AB is training with gradient with a global batch size of 16 or something like that now. So that also contribute to that. The batch size we should be aiming for is like 1,000.
Got it.
Okay, so the main problem here that I think is very important to how we can do this contract is memory. We already had this problem before training BERT, that we seem to be using a lot more memory than so if we think about what's the bare minimum of memory we need to use, it's the weight, it's the gradient of the weight, it's the optimizer state of the weight, so 2 sets of that. So it's roughly like 4x of your model weight. And now we are at, I think, 20x. So there's 5x of diff here that it's either the intermediate states of some kernels because we generated why we don't need to, for example, flash attention. If you just get 3 small input in and 1 small input out, then something like that. You don't need the intermediates. There are definitely more places that say for the activation, it's not clear if we are storing both end of the activation or just one end, and it's also not clear if we can just say we want to regenerate instead of recompute instead of like storing it for backend.
Yeah, so I'll warn you that Rangerify is not going to address any of these.
Okay.
Rangerify is going to address two things. So even the flash attention thing, like, it depends what the backwards of flash attention looks like, right? Like, if it's just generating intermediate buffers and the intermediate buffers are only used on the forward, then that's not going to increase your memory very much, right? Because it's going to be
it's more of a allowing single kernel to have multiple reducing it, and if it knows that the intermediates are very big, you might as well just like squeeze it into and don't generate intermediate part.
No, but I don't even think that's a problem, right? Like anything that's persistent memory usage, that's bad.
Yeah.
Is when you have long edges. When you have long edges from the forward pass to the backwards pass.
Yes.
And that's the kind of thing that we have to look for, right? So any intermediate that only exists in the forward pass is not going to really add a sizable amount of memory. It's going to add memory bandwidth, but not memory.
Oh yeah, what I mean is all the intermediates that result also in the backward path.
Yeah. So this is the kind of like thing that we have to think about how we can build tooling for and build tests for, right? Like think about it like you're scrolling across the graph from left to right, and you get to the loss. How many buffers are alive right now? Why are these buffers alive?
Yeah, so technically, ideally we should have a flag that says can force regenerating everything, so there's like no long ranges and everything in the backward can be recompute.
Well,
right.
Yeah, I mean,
yeah. So we should have that setting, and then we can decide, okay, in which case it's better to keep the edge and in, because we might
kind of called like kernelized, you know, when you think about it, right?
Yes, because to some extent, for the really big one, we can afford very little long edges. But anyway, yeah. So that's I think that would be the main.
We have to think about how we want to specify that, because we don't have the best tool. I mean, we should start by having tooling to visualize this, and then think about what we want the semantics to be. But this isn't Rangerify. This is totally different.
Okay, this is not Rangerify.
So don't expect. This is a separate problem we have to solve.
Great. Yeah. So for example, I wrote the optimizer offloading to CPU. It kind of is working, but it's really not that useful when your overhead is 20x and this only save you like 2x. So yeah, we can start to optimize the speed for that transfer, that's for sure. But that's not the main technical difficulty now. Anyway, so I think I will continue working on this, posting what I think will be a good thing to add to the tooling. So in that way, we can iterate faster. Yeah, that's Llama. We only have, I don't know, how many weeks left? 9?
When you put it that way, it seems like a lot of weeks.
Yeah, we have 9 weeks left, and each training will take 2 weeks. So great.
Yeah.
Yeah, okay. Enough blubbing. Let's move on to this. Can I hear you if you are trying to talk? Don't think it's.
There we go.
Yes.
Wait. Yeah, for some reason when I disconnect my headphones, it disconnects everything. I merged an initial assembly analyzer in this with LVM. Still working on SQTT. It's really hard to figure out what's going on. But yeah, making progress on that. I have to basically reverse engineer the binary format. There's literally no docs I could find about it.
Yeah. Isn't there some stuff that I saw linked that had some parsing for it?
It's just a blob. I have to either disassemble it and try to read it. Like, basically, it's the binary binary
Yeah.
stuff, and I guess see how the UI changes.
Okay.
So I think it might be. I mean, the struct should be well known. I think.
Yeah, that's what I mean.
Called data, and that's only like the only information you have about is the data, or at least like I couldn't find anything specific in the headers about the clocks and how those are traced.
What clocks you mean? I
In
mean the CPU clock.
in instruction timing, like it shows you the clocks and it shows you how many of them were stalled, etc. I think that those are derived, but like there has to be some raw format of this was the program counter and this was the performance counter at that time, like that measurement.
Yeah, but this instruction, like instruction tracing, would it be easier to start with like the typical metrics, which is not part of the instruction tracing?
I don't know what you mean by that.
I mean, so I think the first thing to do here, like whenever you're facing like a binary format like this, is to make sure you're extracting, you're outputting as much structure as you possibly can. Like as much structure as we can find in header files and access. Like write a parser to parse that structure. I mean, data, how big is sections? One or is it just one? Yeah, I mean that's basically the with it, but yeah, whenever I found that invest usually kind of what you're talking about with like differential analysis, where you're saying like, oh well, okay, I hex edit the file, I load it in RGP, and then this thing changes. Okay, therefore I know that this thing is this thing. I mean that should be like a last resort thing, and maybe we're there, but yeah.
Going with this.
But cool. Yeah, no, I think it'll be great to see all that stuff and anything. I mean, anything we can get from those, and then it's really just targeting the MI350. I'm gonna probably be there in about 2 weeks with the Rangerify stuff, where I should be ready to just say, okay, why is it slow? Like I should have this much local bandwidth. I should have this much ALU throughput. Why am I not hitting the max? So those are like the questions we want to be able to answer from this stuff. And then eventually we'll get to, I mean, like scheduling. I'm thinking that scheduling eventually does sort of mean two things, right? There's kind of like macro and micro. From any sort of like, it's the same as like any sort of like if you're playing like StarCraft or something. Like you have like your macro, which is your overall like how you want to spend resources. But then there's your micro, which is literally like, you know, like moving the guys back and forth and taking one shot. So I think it's the same sort of thing here, where what we want to do with this kind of SQTT framework is be able to search over the micro. Like, oh, we can like flip the order of these 4 instructions, which is totally fine under the topo sort, and then we get 10% more performance. So that's kind of like the long-term target for any of this stuff. I mean, we want to like automate the profile. The more you can do a guided search, the better the beam or whatever will eventually be. So just to keep the overall target in mind. And then there's also, I saw some stuff posted about the Intel, like basically Intel's SQTT. I wonder if that stuff works on AMD too. I wonder if we can like get any of this stuff working on CPU, because like the problem with over focusing on SQTT itself is it's very AMD specific and even GPU specific, when in theory we should be able to kind of find all this stuff for every platform. Like, I don't know if there's some way to like get these kind of things out of CPUs, but just thinking about how to like, okay, well, what are the invariants here? What are we extracting? We're extracting the number of cycles of latency taken in the instruction. Yeah, so whatever kind of like framework we want to put this in. But great, cool.
Sounds good. Anything else?
I guess that's it.
Okay. Let's move on to drivers. Oh, can you also comment on the CI? CI has been failing, and the only thing I know how to do is resetting the machine and hope it works.
Yeah. So actually, within DCI, we see like 2 problems. One is the seg fault, and the second one, I hope I fix it. I mean, actually, there is one problem with 5090 that sometimes it doesn't return after PCI reset. So I've never seen these, like I can't repro the 3090, 4090, but if 5090 isn't shut down gracefully, so yeah, and you do the functional level reset, it won't return. Like, so yeah, and the only way is just to reboot machine.
AMD, there's a whole bunch of complaints about this with AMD, where AMD will keep up the PSP. They want to keep it up long term. I'm kind of scared that this is some like security feature.
I
mean,
I don't know really. I mean, it's strange because sometimes it returns fine and sometimes it's not.
Is there like any kind of like lower level PCI reset?
Yeah, we can do bus reset, but I've seen the same reports with a Hopper GPU, so that the bus reset also just doesn't help. Yeah, we can try to do that. I can try, or I can actually try to update the firmware, but I think it's not the firmware itself. Maybe it's BIOS or something lower.
It's super annoying. Yeah, it's super annoying if the GPU can get into some state that we can't reset it from, and that the only way to fix it is rebooting the machine.
Yeah.
Yeah, I mean, what I would try to do here is I would just spend some time trying to get like a repro of the crash. Like, can we get something that puts it in the bad state repeatably, and then then we try to figure out how to get out of the bad state.
Yeah, I mean, simply just not load in the GSP, or just load in the some bad data with the GSP. Yeah.
We'll put it in the bad state, and then we have to reboot the machine.
Yeah, I mean, after like several retries, it will fail. I mean, it just kind of, I know it it's just not constantly reproducible, but in sometimes, yeah, it won't return.
Yeah, I would try to write like a fuzzer for this. Just something that like put in bad state, even if you have to like spam load fake GSPs 8 times. And then because yeah, I mean there's got to be some way to recover from.
I mean, even the driver. I mean, if it's like sees the bad state of the GPU, it just raises an error. I mean, the driver and says, please just do something with the GPU. So it doesn't do anything to reset the GPU at all.
Interesting. So if you insert their driver after it's in this bad state, their driver does not recover. Yeah. I mean, okay. In the worst case, we just have to reboot the machine. We can automate that.
Yeah, no,
But
actually, that's the problem. Happens only if like I mean, we just gracefully shut down the GPU in all cases. But I mean, what I fixed today is I think some driver tries to probe the GPU while it was like some AST driver. So just ask DRM to probe the GPU. And I think that was the collision because we also were using the GPU. So I just disabled the AST driver. So maybe it's gone now.
wait, what driver?
AST.
AST? What is that?
Yeah. It's something VGA related. I'm not sure exactly what place.
Oh, well, AST, that might be the BMC. That's weird. I'm pretty sure that the BMC on the Tinybox is called AST. Yeah. And then that has a driver. I mean, the AST is a video card. Like that's how like the BMC remote control thing works. But surprised that it would be probing the NVIDIA. But yeah, that might make sense. But yeah, no, good to disable that. Yeah, I mean, top priority is making this CI stable.
Yeah, I just also tried to repro like the seg file with the GDB attached, like for 3 days. I know it just worked fine, but it still happens in CI. So
Got it.
and the only time I just caught it was like the Python related. Yeah. I
How
still
we
have
doing?
fuzzer running, but yeah.
Cool. How are we doing on the 350x stability stuff?
I fixed one tuple with the scratch buffers, but still, yeah, I still see like weird issues with Beam. Maybe not very often, and actually, it's really strange behavior, and I don't really understand it. Actually, from the driver perspective, 350 is really similar to 300, MI300. And
yeah,
no, I mean the strange behavior is that if I just increase multiply the scratch buffer by 4, like MI350 will just silently fail for a kernel. So and that's really strange, and I don't understand why. Yeah.
Is that more scratch
just
buffers than is available on the chip, or?
No, I mean it's just allocated on the VRAM, so it should be fine. I mean MI300 works fine with this.
Wait, scratch buffers in VRAM?
Yeah. I mean it's yeah.
So what's going into the scratch buffer? Is this where it's like storing like the registers, or like stores the state for?
I think yeah, so some stack related things.
Yeah, I mean, there's a lot of jankiness around this on the RDNA 3 cards with like the wave restore stuff that uses that thing. But you know, I mean, we have to figure out if we're still failing on Beam, we absolutely have to get that fixed.
Yeah.
So yeah, that's probably top priority.
I thought maybe it will worth it to just try AM on MI300, but I don't know if like more debugging from AM will help to close the problem. But I just double check the code, like in all the calculations we do. I mean, it's correct and matches AMD stuff.
Yeah.
So yeah.
I mean, yeah, we can switch to. We don't have AM on MI300X yet, do we? Or either of them?
No, we don't.
How much? What are we missing?
I know. I mean, basically, we need maybe some refactors, or just not refactors, just to support JFX 9 and the refactor to support XCDs.
Cool. Yeah, I mean, whatever's gonna fix the stability. I also think that we're gonna have to add AQL support.
Mhm.
I mean, I spent a day looking at the firmware, and it looks like because there definitely is some hot sync path that the GPU is using. There's some sync path that's not doing an atomic in VRAM. But as far as I could tell, reading the firmware, there's nothing exposed to PM4 that can do this. The only hope would be PM4 has a backdoor which lets you put in AQL commands, but I think we might just want to write AQL support.
Yeah, I see.
Yeah, I mean, we got to get that. We got to get that sync time down because we're still spending like 10 microseconds overhead per kernel.
Yeah,
Yeah.
about that.
I mean, yeah, that stuff all adds up. So, yeah, but yeah, I think that's, we got 9 weeks. Let's make sure by the time we got 7 before we got to launch our training run. But let's make sure we got this all super stable, and up to you where the priority for getting AM working is. If the AMD driver is not causing problems, I'm okay with using it. But yeah, we definitely got to fix these beam stability issues and get rid of that 10 microseconds of sync.
Mm-hmm. So yeah, also did some HCQ refactors, and finally we can put CPU compute and like HCQ device compute in the same graph.
Nice.
So also CPU is threaded now, but it's actually one thread for now. That was required for this refactor. But yeah,
Cool.
I think we can scale this.
So the CPU compute's no longer running in the same thread as the Python process.
Yeah.
So one of the things that I'm interested about for that is when I control C it, can it actually kill it?
Yeah, I mean
Okay,
it's
good.
like a demon thread. So yeah,
Yeah, no, because I mean that's always been an annoyance whenever you've been using the CPU backend, where you control C it if it's in the place where it turned the. I mean, it when Python calls out to FFI, it kills the SIG SIGINT or whatever, the handler. But okay, cool. Yeah, I mean we should have a test for that if we can. Just like launch like a kernel that's going to take 10 seconds, and then control C it after 2, and it should kill and clean up nicely. Yeah.
So yeah, also try to profile the chain use Llama CPU offloading, but actually, I mean, if this is not usable with such amount of data, at least for now. I don't see any kernels, but they're collected. I don't know what's the reason for that.
Wait, what is this?
Yeah. I mean, I just try to profile some BERT runs or Llama runs with these, and I actually don't see any kernels at all, but they're collected and they're not displayed. Actually, it may be something wrong with the timeline.
Oh, okay. So you found some visbug. Yeah.
Yeah, I think, yeah. I mean, it's really hard to use with such amount of data, and I think at least we need to optimize it, because it's just like 8 steps of BERT and it's not usable on my Mac.
Really? Okay.
Yeah.
Quaslin, any thoughts on
It's strange that it doesn't show anything. That's definitely a bug. I'll look at that. For speed, I'll also try to reproduce that.
Okay,
Mm,
let's
yeah,
start
because
by
it's
just post what you were trying to do in maybe Viz.
Yeah.
And
Yeah.
we can start from there. Yeah. Because everyone's machine has like slightly different spec. Sometimes you will try, sometimes it won't.
I've had mostly pretty good luck. I like it definitely shouldn't scale. Like it's not like anything in Viz should scale with the size of the buffers, right? The number of kernel launches, sure, but
let's start by having the same, everyone trying the same command in the Viz channel and and deciding what should and what is probably.
That seems like a good way to do this.
Okay. Anything else?
No.
Cool. Also feel free to reach out to the person on Twitter doing the Mac Thunderbolt thing.
I mean, he's either gonna get it or not. I don't think there's that much for me to do.
No, it's like I don't know. We can ask them to open the PR or show up in Discord or something.
Yeah, but I think they'll either get it or they won't. Okay. I mean, it should be pretty easy. You have to write this. I mean, Apple's gotten ridiculous with how much they've locked things down. But you don't need a kext. You can write something called a dext, which is a driver extension. Like, you still need a weird entitlement, but you don't need to disable system integrity. So, yeah, and then there's ways to map. I don't know. My talks to ChatGPT about it, there's not really a way to mmap the bars, but IOKit gives you a bunch of functions that let you do like config reg writes and DMAs. So I think that'd be pretty easy to plug into our stuff. So that bounty is well within doable by somebody.
And then also maybe we need somehow get system memory on the Mac to do P2P. Yeah, some way to access whatever the max version of pinned memory is. I don't know how well abstracted that stuff is, but I don't know. We shouldn't be putting time to this. Someone else can figure this out. It would definitely be cool to run 5090s from Macs.
Okay. Claude, host parrot's not here. UVM is not here, so we can wait until they are here. Next is Onyx.
MyPy infix, and if
yep. So it's almost there. The PRs are low there. I was reviewing some of it. Definitely getting close. Yeah. So we have one that fixes the stream enum stuff, and we have one that merges the Onyx parse and Onyx into one file. Then finally the one that merges that single file into Tinycorp proper. So some small like MyPy issue, linting issue, and making sure OpenPilot is all supported. So OpenPilot, they are trying like a new model, which call into the instructions that we didn't implement before. So we also want to get that first. Cool. Yeah, I think good progress. I have been commenting on the PRs. Hopefully those make sense. And just let me know if there's anything that's like weight on me. And I think it should be good. Yeah, Kama people definitely are excited. They are pretty happy with our support of Tinygraph so far, and they are also using the latest version, so everything is like back to good track. Cool. So other bounties, we have B1TG and Hoove here. You want to say something about your work? Maybe we start with B1TG.
Yeah, the reduced access one. I see it's draft, but I don't know why. Is this closer?
Not the draft PR.
So he has 2 PR.
Yeah.
Oh, there's another
Still
one.
use the old PR.
So use the old PR. Okay. Let me find that.
The new lower last week broke my code. I temporarily hack around it.
Got
and
it.
maybe fix it properly.
Shape 1. I don't know how I feel about shape 1. I'm not sure
Yeah.
what that's trying to do here. But yeah, I mean, I think you're close with this. I don't think process replay needs to match perfectly.
Oh, I got a problem in the process replay. The second stage is match the get program, and the generated kernel can't pass the master verify.
Yeah, that's totally fine. I don't know. I don't think it really has to match process replay. I'm fine with it as long as like I saw one of your changes had something where it changed the number of image reads allowed, and yeah, we can't have that. But if it doesn't match process replay, that's fine.
Oh, okay. I find
yeah.
it hard to get those things passed.
I mean, depends on what kind of diff, right? If your diff somehow accidentally or I don't know, unintentionally change a lot of kernels, then it's bad. But if you're saying, okay, it's just like a few ones that disappear so that it looks slightly different, but that's only very local, that's probably fine.
Yeah, or if it's just annoying to get the thing on master to parse the thing, I'm not worried about that either. Yeah, I'm just worried about things that are actual like functionality changes. But otherwise, yeah, let me know when it's ready and we'll merge it.
So, Chen, you said before the generated kernel should stay the same. You mean the AST or the
No, the
source
source
code?
kernel
The source code.
Because definitely your AST would change. Not definitely, but very likely that would change because now you are
Yes.
changing the semantics of those reduced axes. So the argument or I don't know the output of that would be different. But since one in shape is never real, it shouldn't change the output kernel source.
Oh, the for the meta is the C code. You mean the kernel source? Is that right?
Yeah, right. Like in theory, the C code shouldn't change, but I'm not super hung up on it being identical. Like only if there's
But how can that be different?
the names, literally the names.
Oh, sure.
Of the things,
I mean,
right?
if the difference is like RIDX indexing now is, instead of starting from 0, it starts from 1, that to me can just
Okay.
be the same.
Yeah. Like it doesn't have to be byte for byte identical,
Yeah. But if your kernel suddenly have one more for loop,
Yes,
then
yes.
that's bad.
Yes, it shouldn't change the loop structures.
Yeah, that's what I meant.
Yeah.
Okay.
Yeah, they don't need to be byte for byte
Yeah,
identical.
under the hood, the compute should be the same. The symbol name can be slightly different. That's fine.
Yeah. Even I mean, yeah, it should. Again, I'm even going to be less picky than this. I mean, I'd like to get this merged. As long as there's no like regressions in speed of anything, then
Yeah,
we're good.
and I mean, it doesn't also need to be a 1PR if you like, and you have like smaller changes, like maybe just change things locally. We can also merge that separately.
Okay. I don't think it's ready now.
Okay.
The lower stuff seems very bad.
Yeah. So don't write hacks. Try to understand in what stages one are capped, and see if you can like remove it gradually or just remove it at one go. That's fine. But don't write more stuff just to. This is supposed to be making stuff simpler, so not adding more functions and states to work on this.
Okay. That's because the X because it don't keep dim anymore, so the I can't get the axis in the callback.
I don't know. I will need to see a more specific example to like you can describe like what you want and what it's not happening. Then I can maybe take a look. But anyway, you know the drill. You know the principles. We want the under the hood behavior to stay the same, and we want the intermediate representation to change to change the behavior. So whichever way
Okay.
you find easy, and again, similarly, I don't know what's the best way to deal with this because for the moving upcast one, I probably have like 10 PRs that each change things smallly that I can understand. So I don't know if this is easier for you. Just let me know. I can review this whenever.
Okay.
Cool. We have training, stable diffusion. So I don't really know how long it's expected to take. If you can give me, also it looks like your link doesn't give permission.
Your weights and
Sorry
bias
about
link.
that. Yeah, I
No
need
worries.
to fix that.
Yeah.
I'll fix that after the meeting. But yeah, I mean that 1 to 2 day, it's like roughly 32-hour estimate, assuming that like if I, the reference smallest batch size is 512, I think, and that converges after like 3 million examples.
Okay.
And so it'll take me 32 hours to process 3 million examples with my current training loop. I think it could be a lot faster just based on I'm only getting 70 teraflops. In the theory.
So, let's see. So I'd like to see how you expect the full run to take. It can be, you can extrapolate this from our previous submission on BERT and comparing to other people's submission and their submission on stable diffusion. I'd like to see that estimation. Then
I don't quite understand what you mean. So I'm comparing to the MLPerf reference, like their number of examples.
yeah,
So-
I'd like to know how long you expect the training run to take.
Yeah, I'm saying if I ran the training run on the full data, which I could do today if I wanted, I would
Okay.
expect it to take 32 hours.
And how long
If it converged in the same number of examples.
Cool, that's fine. 32 hours.
Yeah, run it. Let's see if it converges.
Okay,
So
I can do that.
if you give me an instruction, I can run this on MI300X, and that should finish a lot faster. That also
Understood.
works. Yeah.
I mean, I kind of want to just try it and babysit it since it,
I mean, if you are,
Oh, you want to just give him access to MI300? X? Okay.
let's see. Oh, let's
Also
try
the
the.
data set-
Yeah, let's start with the 32-hour.
Yeah, 32 hour on a red sounds good.
Yeah, 32 hours on red, and it will be good if you can also have some like logging, the WMB link. Then if it all looks good, then sure, bounty is yours. Then I'd like also to try that on MI300X.
Yeah.
Okay. The data set's like 800 gigabytes. There's enough room on the RAID array on TinyR5. But it's like most of the free space. Can I just download it? Like the full training.
Yeah, that's fine.
We don't have enough
Alright.
drive now. That's
What?
not there.
R5?
Yeah.
Should have.
No, but we have a lot of there's like 1 terabyte for Bird.
Oh yeah, you can use
No, don't delete Bird.
No, don't delete anything. But yeah, you got 1.3 terabytes free. You can use 800 gigs. Sure.
So my only other concern is that it won't converge because I haven't tuned the learning rate for my much smaller batch size. My question, I just wanted to know if I could do gradient accumulation even though it's not anywhere in the reference.
So you can do gradient. Okay. I don't know.
I don't think that changes.
No, because now you can train with effectively much bigger batch size. So I'm pretty sure the reference they all use a lot of batch size.
I mean, the rules for the bounty are whatever is
So-
legal under MLPerf rules. So
Well, that's what I'm asking. Is it legal to do gradient accumulation even if it's not explicitly anywhere in the reference? Like the reference doesn't.
So I don't know about that, but again, if you have a wrong by your estimation 32 hours and it's just off by a little bit, I can run this, or we can grant you access to a much stronger machine and you can tune your learning rate there. But I can only comment after I've seen something being trained. Now it's hard to say.
Okay, that's fair enough.
I mean, it'd be hard for me to believe that gradient accumulation violates MLPerf rules somehow.
It depends on the benchmark.
What
But
I've
they could
noticed
limit-
from reading the rules, like some of the benchmarks explicitly have gradient accumulation steps as a hyperparameter. It's always unrestricted when it is listed.
Yeah.
But it's not
So
listed for
because
other.
in principle, what they are saying is if it's equivalent in math, then it's fine. So I would think yes. But again, I don't think this bounty. If you train something 32 hours and it's just off by reasonable amount that's tunable by hyperparameter, then grant you a bigger machine or whatever, then we tune that.
I mean, definitely to claim the bounty, I want one that hits the MLPerf target.
Yeah, of course.
But yeah, I'm not that worried about. Yeah, just like
So I guess back to practical thing. Yeah, you can just start with your wrong, and if you're confident enough, we can grant you the bigger machine. So that's fine.
that seems
All
good.
right.
Yeah, I just want to see something that's being trained and seems to learn something before granting you more resource.
That seems
all I
right.
Yeah,
ask.
sorry, the current link does show that, but on 0.1%. But yeah, fair enough. All right, thank you.
Sure. Cool. Okay.
Oh, and then the Muon optimizer. I'm upset at how many times I'm going back and forth on this, right? Like there's a bunch of little things, like that fused optim, right? So instead of like, does fuse optim work or it doesn't work? If it doesn't work, you shouldn't just set the default to 0. You should add an assert saying you can't use this flag with Muon. I didn't realize Muon's actually 2D. The shape of the gradient matters.
Yeah, that's what was said.
Yeah, it's crazy.
And so I will leave this to Wolf's parent. He
Yeah.
knows much better than what this should be.
Yeah. No, just there should be an assert for that, right? And then like all this back and forth about the like the momentum thing and the hyperparameters thing, like it should be like this thing has to be usable fundamentally. Like I don't want something that has hyperparameters that they match the other ones. Yeah, but it doesn't work. Right? It's useless. And then I'm still seeing, so there's a momentum change. I'm still seeing multiple changes here that I don't really understand. Like, I don't really understand why you need to check in 3 places if NS params is none. Like, what's different and why? Why can't that be computed beforehand? Maybe it can always be computed afterward. The smaller diff to these optimizers, the more likely I am to merge this. And I see like a bunch of little things in the PR where it's like, no, the word classic is not under the word self. And like it's just little things. It's like, okay, you didn't read this 17 times. So
Okay.
I don't think Kevs is here, but yeah, that's my take on Muon.
Yeah, so because these are like higher level stuff, and higher level stuff is similar to everything we put in Tensor. That's what a user of Tinycorp will read. We don't expect a user to read like lower or much lower level stuff, but for anything in NN, in Optim, in learning rate scheduler or Tensor, user will read. So we want to make sure these are really clean and readable to even like external users. Okay. All about the CFAR.
Oh yeah, no, that's never gonna. I'm never actually gonna do that. No,
Okay.
I should just pay out that bounty. If it's right, it's right.
I don't know what's the issue with Whisper. What's the Whisper bounty?
It's not ready. I always hear updates. They're long updates and they're not ready. It's not ready yet.
No, but this update is saying something else, right? I saw the bounty is just making Whisper running in web GPU.
Yeah,
And he's talking about the model quality and different heuristics.
yeah. I don't think that's required for the bounty. I think all that's required for the bounty is that it runs in web GPU and it matches whatever the OpenAI reference is. Like whatever OpenAI's reference is, if you show that it's the same quality as that sounds fine to me.
Yeah.
Okay.
I think that's it. Cool. Looks nice. Thank you, everyone. See you next week.
Bye.